Good evening, folks. Bear with me 1 second. I have completely screwed up here. That's not right. I was busy going through my notes from last time to see what I needed doing this time, and completely forgot that I hadn't plugged in the microphone and the camera and all the rest of it. Do give me a second. The camera is on the little tripod, the big tripod over here, and pick up the keyboard. This is going splendidly, as you can tell. I should know better than to try and do anything in this weather. Secondary camera isn't running. Secondary camera, HD Pro webcam. Yes, there we go. Open interface. Why is that upside down? That's a good idea. Anyway. So you should be able to see System 1 at least up in that corner somewhere. Water. Oh, there was no plan involved, Majenko. I just hadn't got around to transcribing all the fourth we wrote last time. Stupid. Let me put this back on the tripod before I lose it. Yes, thank you, Cobb. So, as I think I mentioned, I just need to say with which to wipe that. Nope, not going to improve on that. Anyway, just to catch up on chat quickly, who have we got in? Hello Chloe, hello Majenko, hello Cobb, hello The Industrious Anti-Saw there, and I saw Dead Insects and Sleepy Developer. Hope you're all well. Chloe, the clock running when the video isn't yet is because you mentioned Shelby. It was actually I noticed my first few streams, the beginning of the intro was getting cut off, so I was sending it but it wasn't making it through to the VOD. So I asked Shelby, how do you line yours up so that your countdown starts at 3 minutes in the VOD. He said, "Oh, I send 5 seconds of blank video before I start." So yeah, I'd been doing. I'd been sending a couple of seconds of blank video, but it turns out you do need to send 5 or 6 to avoid it getting cut off. Good evening, Carrot House. How are you doing? Let me just have a look. So, as I mentioned, what we are looking at today is the 4th implementation of System 1, which has a couple of minor issues. There's one usability issue which tripped me up last stream and trips me up occasionally, which is that when it hits a parse error, so it doesn't know what you've typed, it just tends to go off the rails and spew lots of error messages. It would be better if it abandoned the parsing at that point and didn't try and parse the rest of the line, because if you've typed a whole line into a definition, then low battery, your Mac will sleep soon. That's not good. Hang on. Have some electrons. It would be better if it discarded the entire, or discarded everything after the error rather than struggle on, because if you've done this in the middle of a definition, you can't go back and correct the error if it managed to parse something successfully.
RHK77 cheered with 100 bits. Hi Ben.
Hi RHK, how are you doing? Thank you for the 100 bits, most appreciated. Sorry, just... So I want to fix that so that the error messages work better. And I want to... good evening, Token Scandy, how are you doing? Good to see you. Want to add a hook in the 4th implementation to let us hook up the keyboard driver that we wrote last time, so that we can actually type out into the 4th rather than just into a program running in the 4th. So that's the plan. Whether we get anywhere is another matter entirely. Why is that camera drooping again? Let's try that.
Cop 2015 cheered with 50 bits. Blackadder goes system/1.
Thank you for the 50 bits, Cobb, much appreciated. That's a scary thought. System 1 is definitely a cunning plan of the Baldric variety rather than the actual cunning variety, yes. Tokascandy, we're trying to get the serial working. Spoiler alert, it doesn't for the rest of that video. That turned out, yeah, it was a hardware construction fault.
Majenko Tech cheered with 50 bits. Blackadder, back and forth.
The least of the Blackadders, Majenko, yes, but thank you for the 50 bits. Anyway, where are we? We are going to crack on with that. So what we want to do is bring up the thing. There's System 1 and there's the terminal running on it, so we can see the state of play at the moment. So if we reset deposit start, that's not useful. What's gone wrong here? Well, apart from it being upside down, bear with me. The other problem is that the printer is turned on. Right. Reset deposit start. No, now the terminal is wedged waiting for the printer, so we want to clear comms. Reset terminal. Yeah, right. Should be able to read that upside down, should I? Right, reset deposit start. Okay, we've got that far. And while the 4th boots, I shall try and work on getting the open to face the right way up. That one. Okay, we'll have to do this transform, rotate 180 degrees. Well, that hasn't helped either. Right. If I do that, there we go. For some reason, the video from the open face is coming in upside down. OBS appears to do this occasionally. I don't know why. I've had it occasionally show the webcam upside down, and the only solution I found is to restart OBS, which is not really an option in the middle of the stream. But anyway, there we go. So to demonstrate the issue I want to solve, let's try. If we type in a word it doesn't know, it tells us that parse error after farts. If we were to do something like 1 plus farts dot enter, we get parse error after 1 plus farts, but then it carries on and it runs the dot, which is the print, so it says 2. Closing some tabs isn't going to help, is it? Come on. It's something wonky about which way up it thinks the video is. But anyway, so what we want to do is first fix that missing carriage return. I think it's just sending a carriage return, not a line feed. Can I divide by farts? Probably not. 100 farts divide. Parse error after 100 farts. Well, that sounds painful. So we want to fix that. But the real reason this is a huge problem is if you're in the middle of a definition. If you could spell definition correctly. Definition, yes. You might be saying, I don't know, 2, 3, if cheese then plus dot whatever. And now if we see definition, it's just skipped the cheese because it doesn't know what the cheese was, it's just missing. So now your code is complete junk. You've got no way of going back and putting that missing word in. It's just carried on assembling or compiling the rest of the word. So what we want to do is switch on over to excuse me. Where are we? VS Code. No, come on. Where are we? Secondary.
A swarm of dead insects cheered with 100 bits. None definition with left cheese.
That sounds good, Swarm. It's a bit hot for a pizza, unfortunately. Anyway, so what we want to do, those are the notes I was taking before I realised it was 1801. We need to hop into the assembler yes, it is in the assembler part of the fourth call. So if we look for parse error after, why are we getting parse error after? 13 works, and oh, I see, it's 1310. So first off, let's fix that missing new line. Let's get my glass of water out of the way. So that will at least put the cursor on the next line after an error. And let's see what the parse error, either not a known word or not a number in the current base. Print error message followed by some context. So error occurred just before the cur key position. Makes sense, because we'll have scanned a word out of the buffer and then decide we don't know what it is. Find the length of the buffer up to that point, capped at 35 characters. That seems reasonable. And then just print the string with a given length. So what we want to do is we want to indicate the word that was a problem. So we could scan backwards from that point for the previous space and underline it perhaps, but it's probably going to be easier just to we'll just stick an arrow underneath the word that was the problem, I think. So that's printed the string and a carriage return. So now we want to context string. Does IO print bytes destroy the length? I think it does. It does indeed. So we want to beg pardon. Start a context string there, length in R1, so we want to stash in R. What is safe to use? R5 by the looks of it. So into R5 we shall put the length minus, so we're currently pointing at the space after the word. So I'll subtract 2 spaces before error indicator in R5, and then we shall move R0 32 space 8. Print byte. So jump WL, jump with link. We don't have a call instruction in system 1 because it doesn't have an actual hardware stack at all. So what jump with link does is it does a jump, but it puts the return address in register F here. You can specify which register it is, which just means that the routine can then stash that somewhere on its own stack, or it can jump to that to do a return. So that's what jump WL is. I've just noticed a bug in my syntax highlighting. That's weird. The keyword after a label doesn't get highlighted properly. Okay, something else to fix, I suppose. So dec R5 jump if not 0 8b. So go back to 8 until we've printed that many spaces, and then move R0 a caret jump WL RF IO print byte. And then CRLF again. So this is where things get a little bit tricky. I need to make file where is it system1 tools, go away, awesome. Should be it. So let's see how badly this works. Okay, well, we've got an error. That's a good start. How large is the register file? 16 general purpose registers, and then a program counter and a shadow program counter. Yes, take a scan. I thought you might. It was. I wanted to brush up on my test-driven development in Perl. So obvious candidate project. And in fact, the tests found an error when I upgraded to a new Perl version. I can't remember what it was now, but that was worthwhile. Unexpected error. Move string caret at 4th ASM 1444. Oh, I probably need to translate that. Okay. Man ASCII. '94. Okay, that's good. No errors in two source files, and we should have a 4th barebones.bin. RHA, yes, RF. So register 0 through register F for the 16 general purpose registers. Oh, speaking of resistors there, 47k ohms, I did manage to successfully remove that mistaken 2.2k resistor from the RC2014 Wi-Fi board without damaging the colour on the board. Let's see if I can... Safari off. It's not Safari anyway. So it's not going to focus on that, is it? I'd need the other camera. But yeah, there's no ill effects to the print, so we can go ahead and fix that up on Tuesday. Indeed, Cobb, yes. So what we want to do is figure out how to get this code into System 1 for testing. And this was fairly easy once upon a time. You would just squirt it down a serial line. Because the bootloader in System 1, if we turn on the... if we reset deposit... start... we can press any odd key there and just send binary into RAM, which is what we want to do. The problem is, A, we've got it hooked up to the VT240 so that you can see what's going on. So what you can do is plug a printer into the VT240 so that anything that you send to the terminal goes to the printer as well, optionally, and also anything that the printer sends can be sent back to the host. So the idea was that we plug the laptop into the VT240 on the printer port, and that way I get a transcript on the laptop of everything that's going on in the 4th when I'm writing stuff, but also I can then send the binary up to the system that way. So I built well, let's put it over this side. Let's turn that off and put it over this side. One of these adapters which takes standard, well, not, I can never remember the EIA standard number for this, 459 or something, for the IBM AT style 9-pin port, and on that side it's the DEC pin out that the VT240 expects. So what we can do is plug that into the VT240. I've got a flying lead hooked up to it, and then a null modem adapter and a serial cable to the laptop. But I don't think this serial adapter is quite up to spec, or at least the VT240 isn't too happy about it. So if I bring that back up, what does it say? Address is in register R0, so we've received a byte already. Stop. Deposit nothing, restart. And we want to check this is set up correctly. So printer to host is on. 9600 801 normal print mode, so it's not trying to send anything to the printer. It says printer ready. This might work, it might not work. We're about to find out. So what I want to do is bring up CoolTerm. If I can find it, there it is. Clear data. What's gone wrong here? Turn that on. Move that down here. So what we want to do is send text binary file. Oh, you can't see this because OS 10, that's fine. Command Shift G gets system 1/4 barebones dot bin. No, first I want to actually set this up so it puts a. No, I don't. I'm being a prat. Fool. So, okay, good. We can see, you might be able to make out there the lights flickering as it counts through. Oh, you don't get to see the progress bar. That's a shame. 82%. Right. That's all sent. So what I want to do is change this over to auto print mode. And if we then deposit 0 in PC and start... it doesn't work. Why not? Stop. Deposit. I think this is more fundamental, Chloe. I think it's because I know that this serial cable setup isn't right. I used to use an adapter I built myself which had a MAX 232 on it, so it was definitely standards compliant, but it's acting up. It would probably work okay for this, but I don't remember where I've put it, because it was acting up. I put it somewhere to repair, and we'll have a look in a minute if we don't get it any further. But what I want to do quickly is we're going to bring up, no, not that, Pratt. Anyway, you might have just got to look at my old copy of my CV, never mind. So what we want to do is read the bin.sim, there we go. And somewhere in here should be a list of, no, boot vector 0, full 8. So let's track it through some execution. So we start at 0, then we have 4, 8, C. And then 100. No, sorry, 10. So that's what the first few words in memory should be, so let's have a look. Memory address register, deposit, read. Alright, so 0, 0, 0, 0. 5, D48. Well, that's nothing like anything we've got there. Now what's that one? 1, 2, D, D, 5, 2, 1, B. Eh? One, two. Well, there's 1, 2, D, D. Yeah, this is. Okay, what I'm going to do is unhook this from the VT240 for a minute and just try sending the file directly over. So bear with me for a few minutes while I recable that. Whoops. Yep, let's do that. That's a good idea. So switch this back to cool term, like so. So if you press enter there. No, let's press space there, let's be sensible, and send file fourth.bin. Evening Dopaz, good to see you, thank you for the 30 bits. Right, so now if we press stop and no, put 0 in the program counter and press start. Well, compiling initial workspace parse error after Eldritch Horrors. Yes, I use Hexfiend a lot, just because I was within the IDE, it made sense to just OD it in the, or XXD it in the terminal. It looks like it, well no, actually let's have a look at the hex, view hex. Parse error after. That doesn't look like... That looks more like noise. It's too high entropy to be System 1 machine code. What? And the fact it got there immediately is suspicious. Let's try again, because that will definitely help. Okay, it's trashed something. Let's just make sure we're not sending data too quickly for it. Transmit character delay. 10 milliseconds, why not? Data handling. Okay, that should be good. And this is going to take a lot longer. 4%, 5%. Well, thank you very much, Majenko. I love you too, mate. I have not calculated the entropy, no. Just I know that it should have a lot more zeros in it, basically. We can take a look in a minute at the what the binary looks like in the editor. In fact, we'll do that now because this is taking a bit longer than it was before, for obvious reasons. I've put a 10 millisecond interbyte delay on it. I just need to find the right window. Well, I must look up if I can set that anchor point. Anyway, doesn't matter. So if we look at the this is the machine code section of the binary. There should be a lot more 0 bytes floating around, and then when we get down to this section here, this is the 4th workspace, and that is 4th. So that should all be printable ASCII. That is all printable ASCII. In fact, let's XXD it instead so you can see that. What's all this? Well, there's all the 4th that it should be parsing. I mean, I would suspect it sort of ran over the end. What's this at the end? Oh, it must be all the machine code words. Drop, swap, dupe, over, rot, to drop. Could be. Anyway. But yeah, that's not what that block of noise looked like. JTAG debugging facility. Possibly. I did think I had to implement the GDB remote debug stub at some point. But I didn't get around to it yet. So where are we? We are looking for a call term to see if it's done. It is done. Excellent. So if we switch OBS back over to looking at that. Well, we'll try again just for good measure. So stop PC to 0, start, stop. Hmm. Okay. Good evening, Jeepin. Good to see you. Don't worry, you only missed me making a complete hash of things. Is it the same as before? Your guess is as good as mine there, I'm afraid. No idea. What I think we'll do, let's revert the changes I made. So VS Code 4th.asm, and we should be able to. Yep. Change to 0. That should just be the ASM path. Yeah. So we only made a few changes, but we'll stash them. We shall stash them. Discard open. Why do I not have a stash option? Well, that's rude. No stash option, but there's a fucking Copilot button. Fuck you, Microsoft. I think I'm going to go back to Sublime Code, you know. At least I never had to write a full-blown bloody extension for Sublime to add custom syntax highlighting. Right. So, now we can remake Pillock. Oh, it's pop, isn't it? Right. And we'll try that again. In fact, I'm going to do this. There we go. Now we've got both windows up there. Start the serial bootloader and send file. And if sending this file doesn't work, then we know it wasn't a bug in my code. We know that it's something to do with the serial lash up I've got going on here. At which point we will be vaguely stuffed for the rest of the stream. But we'll see what happens. I mean, yes, I agree with the general sentiment, Swarm. It's ridiculously heavyweight. Why did I try it out originally? No idea, but I decided it might be. I decided to give it a go, and so I wrote the initial implementation of. No, I wrote the initial implementation of the assembler on the other laptop, which didn't have it installed. It must have been because I forgot to install Sublime Text on my travel laptop when I was on a train to Edinburgh, and wanted to work on the System 1 assembler, but I did have code installed out of sort of perverse curiosity more than anything. So I decided to have a go at working with it then. Then I wrote the syntax highlighting for it, for System 1 assembler for it. But yeah, it was okay at first, but it's just getting annoying. The Git integration is pretty poor. You have to add extensions to get things like stashing support, and even then, the editing box you get for writing commit messages is absolutely uselessly tiny, crap, awful. So yeah, I like I said, I think I'll go back to Sublime Text at some point. Right, so file is sent. As you can tell, you didn't see the progress bar, but it's gone back to an active window. So I can stop, deposit. No, same error. And I've been a complete wally. And I pressed clear contents. It does look like different junk each time. Let's have a look. It starts with New Jersey yen. Is that yen? Yes. So let's clear data, deposit, and it's completely trashed the image. So that's very weird. Deposit start connection send file. And while that does that, I'm going to switch back over to VS Code and see if I can remember how it gets that IO bare bones. So we go read line. No, so the ooh. Minified.f, prepare for patch. Bare bones, image. Fourth.asm depends on minified.f. Right, so. Okay, there it is. So how does that work? That runtime to runtime top. Yeah, so the way that works is that it includes the base workspace is a pile of Forth that is originally a massive great file like this, with all sorts of commentary in it. You probably can't see. Where's OBS? So Jones Forth has it all its environment runtime sort of stuff defined as literate Forth like this, but of course that takes ages for System 1 to plough through to parse. So the build process minifies it into a format like this, with all the comments stripped out and unnecessary white space removed, one definition per line, and that gets included into the binary. Oh, we saw it was there when we looked at the hex dump. Okay, so it's definitely there. We know that much. And then at boot, the Forth runtime, the machine code section of it, treats that as the initial input buffer. So it just should plough through the whole lot. And it should take 30 seconds. And the fact that it's doing it immediately is suspicious. So stop. PC0. Okay, it is the same garbage each time. Or at least it hasn't changed since the last run. Okay. So I'm just trying to reload it there. In case the boot ROM sets up a few parameters in registers, such as the address of the... Oh, you couldn't see it. So the boot ROM sets up the address of the serial board and the top of memory in registers before it jumps to Forth. So I was just making sure that that was happening correctly. At this point I am somewhat flummoxed. What would really help would be if I could find my old serial adapter. Give me a minute while I shuffle around on the table. It's got to be here somewhere. That is adapter for the Rainbow. That's a bag of jelly babies. That's not going to be the answer. That might be the answer. You never know. Nope, it's not there. Bear with me one moment, folks. No, I'm afraid I cannot find that, which is... Is this looking down there? Is it looking down there? It is not, no. No, can't think of anywhere else that could be at the moment. The problem is, I discovered an issue with it when I was working on System 1 a while ago. I think the first stream I did with it, getting ready for that. There's some sort of issue whereby it sort of echoes back all the characters it receives, just damaged as sort of runt pulses that are big enough to trigger, or for the other end to receive it as data. So it's sort of doing a local echo type deal. And I realised that had been what was confusing my logic analyzer when I was trying to do screen prints and such. Like, anything the logic analyzer sent to the laptop was getting echoed back to the logic analyzer, and it was obviously throwing an error because it didn't understand the commands it was being sent. Anything being sent from the laptop out gets through unscathed, so it should be sort of almost sort of fine here. We could work around that just to dump code into System 1, but if I can't find it, then it's not much bloody use, is it? Unless it's in my pot of broken crap. It is not in my pot of broken crap. So that's irritating. That's extremely irritating, because we are now stuck. No, it's not. It might be on my desk where I was. Yeah, it probably is. Yeah, give me a second. I'll go and see if it's on my desk where I was looking for the right model number of the Max 232 family to fit to it. No joy, I'm afraid. GPIN, yes, basically. No, it's because it suppresses the noise while the clattering is banging as I chuck stuff around with wild abandon looking for missing bits and pieces. So, can't find that, so we cannot go any further with System 1 today, which is annoying, extremely annoying. We shall have to build a new one. I have, I think, a spare PCB, because that was part of my typewriter conversion project from years ago, so maybe we'll look at that sometime, build a new one. I can also look for the old broken one, which worked better than its replacement. The old broken one broke because I was using it to test an IBM modem, which weighs several kilos, and I hadn't realised that the modem was covered in sticky goo because the rubber feet had degraded. So I'd put it in a plastic tray on the table to test it, and I hadn't realised that the USB serial adapter was protruding out of the back and supporting the entire weight of the thing on the micro USB connector. which promptly tore off the board. So we can try and find that broken example which worked better than the second attempt and resurrect it, and if that fails we can try and build a third one at some point. But yeah, hi Rumdog, how you doing? What went wrong is we tried building a minor change to the fourth for System 1 and then sending the binary down to the thing, and it fails to run. It just goes haywire. And I think it's an issue with the serial adapter I'm using. I'm not certain. Let's try one more thing before I give up entirely. Let's bring up... I hate you, Milkman OBS. That one and that one. There. That there. Stop it. My God. This software is determined to drive me crazy, isn't it? So let's start again. Reset. Deposit the boot ROM address in PC. Clear data. Start. Serial bootloader. Send text file. Fourth barebones.bin, which should be the fourth that was already running because it's in ROM. With the only minor change being the build date actually. And while that's doing that, we'll switch back to VS Code and we shall Control R XXD. No, it's not what I wanted. Control R OD. Dead beef. 7. So we can at least we'll examine the first few words of memory once this transfer is complete and see if they look sane. And if they don't look sane, we might have some idea what the corruption is. I don't know what you're talking about in chat, but I'll leave you to it. Anyway, has that finished? That has not finished. What we can do actually is switch that to there and get an address of how far into RAM it is currently writing. Once that is, yeah, so examine that. If that doesn't give us any clues, what we'll do is we'll abandon this and we shall switch over to the RC2014 and fix that cocked up resistor. How does that sound? How big is this file supposed to be after all? Oh, 99%, 100. There we go. So where are we at? We are at 300C. 300C. Okay, that's right. There's probably an easier way to do that. You can see, probably an easier way to do that conversion, but I was feeling lazy. Can I toggle in the few No, because it would have moved everything after that point. Not entirely sure which point that was, but we can find it out later. But yeah, so let's just quickly review those first few. Stop. Memory register, address register 0, data register read. Okay, so that's 88000014, so that's correct. 07, that's correct. 8860, all the zeros, all the zeros, all the zeros. 710D C. Okay, this is weird. 710C. Huh. Let's trace the execution flow of this from the start and see if we can get anywhere that way, because that's all looking absolutely fine. So that should jump to IO init, which will be so it should jump to 18 after the first instruction. So program counter back to 0. Step 18. Yeah, okay, that's good. Jump to prepare interrupts. Did it fail to take that jump? Where are we at? We are at 5.8. IO prepare ints. Okay, that's where we should be. Oh, that's interesting. Okay, so that should put us into accessing user mode. Enabled interrupts should leave. And now where are we? We are at 4C. So that's back here. So R0 should become the address of the IO sign-on string. Ah, but we knew that worked. IO prepare inst. Let's set a breakpoint at 5.4. 5.4. PC break on match. That wasn't the button I wanted to press. No, that was no help whatsoever. That should have stopped when it printed this message here. Parents 5.8, so we stopped at 5.4. No, we didn't. I set a breakpoint at 5.40, not 5.4. Ah. Let's try that again. Ooh, sausage and mash. I approve, Chloe. I think I'm on the pasta bake later, but we'll see if I have the remaining brain power to deal with it by the time we get to that point. It is probably the Ben Kicks Himself stream, yes. We'll give this one more shot. Yeah, so I'm just going to go back and read the fourth a bit, or read the. So it jumped to fourth start from there, and that is in fourth.asm. Oh, that's a lot of stuff to get through before we. Cold start. So cold start just as a quit, which starts the interpreter loop. Actually, that's where we want to stop, at the key routine, which should load the next byte from the input buffer, which should be the that minified source code. So if we stopped there, and traced through a bit, we should find the point at which it's starting to read code and then is going off the rails. 97, 98, 99%. Done. So, stop. Deposit 0 in the program counter. And we want to find the address of that routine underscore key in the symbol table. E to C is the breakpoint we want. So E to C. Is that right? E, yep, to C. Break when we hit that. So when I hit start, we should see the sign-on message appear, and then it'll stop. Yes, there we go. So we are here. So let's execute that one, that one, that one. No, Pillock. Oh well, close enough. So register 1, current key location. Register 2 is how many are left. Which seems odd because that's a bigger number. What? Register 1, current key. Is that 13 FC? 13FC runtime. So that's where it should be, yes. And the top is 295E. So, hex 295E. One 13F8 subtract 1566. 1562. Yeah, it's probably fine. Oh, because there's a null at the end. Okay. Oh, it's just coincidence that it happens to be about half the... Yeah, if it starts at 13FC and it's about 1500 long, then of course those numbers are going to be very similar. Okay, that's fine. That's fine. I think the difference of 4 is simply... Well, let's double check that theory. If we look at the minified runtime top. So start address, end address, buffer top, end address. Good question. Runtime 13FC 295E. Yes. Enter. 13FC. Subtract. 1562. I made a typo when I was doing subtraction myself. Okay, so it's better at maths than I am. That's good to hear. So it's reading from the buffer correctly. So where are we? Program counter. E2C. E2C. Eh? Oh, E3C. So if that's 2C, 30, 34, 3C. So we're at this jump here. Have we exhausted our input buffer? No, so get next key. Load R0 from R1, increment R1. Advance the pointer and return. So R0 should now contain the first byte of the workspace, which will be a colon. A. Correct. So let me just check I have the breakpoint set correctly. E2C, we do. So if we hit start, it should consume that colon and then it's starting out running okay. Let's have a look at the minified source. So we should be compiling this word So division is div mod, swap them over and drop the mod. I'm wondering how we get to... How do we break it at the parse error? Yes, thank you, Majenko. Let's parse error, error message there. So we want 6. Label 6 within code interpret. So the interpreter in this forth is written in assembler. You could write it actually in forth, and it might actually be better to write it in forth. There we go, 6. So we want to break at 134C is where we print the error message about parse errors. So stop at 134C. Should be interpret labeled 6. Let's see how we get there actually. Dictionary so a literal number. Sorry, I'm just looking to see if I can easily figure out what, from the point at which it fails, if we can easily find the last word it consumed. Get word returns address in R0. Then we do a find. It wasn't in the dictionary, go there. So R2 should be 0 because a dictionary is not a dictionary word. No, okay, let's just break at this point and see what happens. Well, enjoy dinner on Top of the Pops, Token Scandi. I shall catch you in the pub later. So, bring up that one again, and we'll hit go. And there we've stopped because we've hit the error. So error occurred just before cur key position, so let's find cur key. It's in memory at 2FCC. So CCF2, 2FCC. Deposit read, and we are at location 1417. 1417 is not flen mask. What? Oh, I see why. That there's just constants that happen to have one F2 and 80. So those are flag values. That's irrelevant noise. So we're at 1417. which is in between runtime and runtime top. So we have hit a parse error. That's 1417 minus 13FC. We've hit a parse error 27 bytes into the minified fourth, which is, let's have a look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 5, 6, 7. So we've hit a parse error after that mod. I don't understand. So might be a GNU had option RHK. Oh, -C. Yeah, what's it not liking about that? Is the ROM fourth still working, or do we have some sort of? No, before I worry about that, I am going to quickly dump some or read some of the RAM at that location. So 1414. Was it read? So what do we have there? We have a 2F 2F2044 2F2044 2F 20. So that's 2F20. Four F. It's lost a. Two F2. 2044. 20444F to 4D. That's weird. That's this word here, isn't it? 2044. Oh, it's not word aligned in memory, so that's not going to help. Blast. Sorry, bear with me. This is obviously not scintillating, is it? Deposit read. So we want to look for 2F 2044. Oh, look, 2F 2044. Endianness 4F 44202F. I'm confused. Key switch talk, is it, Majenko? The KO box navies. Yes, I understand that the pale blue is basically a bug fix of the navy, and there's a similar one.
RHK77 cheered with 50 bits. Was the 27 bytes a hex value or decimal?
Decimal RHK. But I believe there is also a bug fix of the Kale Jade similarly to the Pale Blue, which is a shame because I've built 128 of them into this keyboard. So I'm just going to make a note in a file of what we're actually looking at here. 2F 20444F, and then in the next word we have 20444F 4D, then 504F 5 2 4 4, and 3A 0A 3B 20. Off the top of my head, I'm not going to be quick enough at this. So 2F is a slash, isn't it? So we have slash space D 4, 4, 4, 4. I'm going to push D-O slash space D-O space D-O-M 4D P-O. It's going to be an R, isn't it? 52. D. 3A. That looks suspicious. 3A colon. LF. 3B semicolon space. And then endianness wise we've got a OD slash MOD space drop space semicolon line feed colon. So that looks right, actually. That is the end of that. So what we're missing there is colon mod slash mod drop. And where was that starting in memory? That was starting at 2, 8, no, at 1, 4, 1, 1, 4, 1, 4. One, 4, 1, 4. Oh yes, that was there. To FCC. To FCC. 1, 4, 1, 7. Reads like that, so that'll be at 4, 1, 4, 5, 6, 7. No, 4, 1, 4. Be there. 4, 5, 6, 7. It's as if it doesn't like the slash. I don't understand. Why would this code... Is it assembling it differently to the original code? How can I extract that from... grepsys. No, not grep. Find dot hyphen name star dot bin. Oh yes, start off OS 10. I'm just going to see if I have a dump of the ROMs on here that I can easily know. Unless they're .1. No. I am going to go back to here and check that the 4th that is actually in ROM works still, and that this isn't a hardware failure of the computer. Yeah, okay, that's fine. Wait, what's the difference between Git37C056B oh, for God's sake. C056B. There was that one there. Oh, the difference is I was reading the git hash for the boot ROM code, not the 4th. Okay, so it is built from the same code. It's just built on a different machine. So that was what caused the test failures. And what do I change there? I've just changed the grouping. I can't see how that would make any difference. What I wanted was to find the actual binary boot image from that thing. And this is on my other machine. Yeah. So just blank test dash. No, okay, that's all. irrelevant. No, it's not on my other machine. It must be on the other laptop, which is somewhere. There that is. Let's just see if this has enough battery in it to tell me whether it's got the boot ROM files on it, and it does not, no. I need a power cable for it. And I don't have one down here. Oh well, I think we're going to have to call it there for the day. What time is it? It is 10 to. I'll tell you what, shall I quickly shift all this junk off the table because it's being a pain, and we can spend the last 10 minutes of the stream fitting that mistaken resistor to the RC2014, and we'll see if that works for the terminal thing, the Wi-Fi thing, and then we'll hop over to Shellbase. How does that sound? Because this has not gone well. Let's be fair. I have no idea why. I shall have to dig out the original binary for the 4th and do a vbin diff and see if the assembler's broken. But yep, okay, folks. I shall turn on the lights first, and then I'm just going to go to the standby slide quickly while I move everything off the table, because otherwise it'll be noisy. Right, there we go. We are, whoops, around this side of the table again. And we want the soldering iron. Soldering iron. It has tied itself up with a serial cable for System 1. Excellent. Come on, out you get. Whoever invented cables was a menace to society. There we go. Right, bit of water on that first. And RC2014. No, I said go away with those, didn't I? Go away. And there's the board with the whoopsie. And the crop resistor. So yeah, as I tried to show off earlier, nice clean holes now and no discoloration that I can see anyway, so I'll try and give you a better view of that on Tuesday. Soldering iron would heat up quicker if it was plugged in, wouldn't it? Unplug the BT240. Where are you going? Unplug. There we go. Now find the snippy thingies. Oh, title is set, is it? Don't tell me it's more data general stuff just to annoy Cobb. Aha. Well, there we go. We shall tune in about 5 minutes then. So. Why? Oh, it has warmed up, okay. Where's the solder gone? The solder's down there. Come on. Stop wobbling, you stupid thing. Oh, there's the bloody electrolytics on the bottom now, pivoting the board all over the place. Oh well. Come on. Oh, the indexing and archiving, that's the general schedule entry, isn't it? For Fridays on Shelby Streams. Okay. That's better. So what we want to do now is pop this in. It is set to port 1. So if we pop that in here, and disconnect the VGA because we don't want that competing with it, and we shall plug in some power. Like so. And we shall see if it remembered its IP address from last time. Let me just bring up that one, and item 168. It was 3.5, wasn't it? It has. So if we telnet 192.168.3.5 and press reset, hey, CPM. Why did the music start? Oh, because I pressed Shift M. There we go. Countdown running. Set local off. DIR. No. Set. Set echo off. Right. Well, it's sort of working, as in we've got output B, but it's not interpreting the input correctly. So it's progress of a sort. We still have to work out what's up with that weird, because we were seeing FF characters all over the place, weren't we, when we looked at it? With Coulter, was it? I can't remember. Anyway, at least it is now receiving it's just echoing bytes back, which is weird. Anyway, at least we've managed that, so we'll call that good, and we shall...
Majenko Tech cheered with 50 bits. I seem to have a few bits left. Not enough for the deck talk, so I may as well spend them here instead and get something out of it.
Well, thank you very much for the 50 bits, Majenko. They are most appreciated. So yeah, on that note, we shall hop on over and join Shelby and see what projects he is planning to plan. Apologies for the disjointed end to the stream there, but we've got that running, or got that obvious mistake fixed, which is good. And I shall have to go and put System 1 on the naughty step and scowl at it until it learns the error of its ways. I'll let you know if I figure out what was wrong there, but these things happen, unfortunately. So thank you all for joining me. Yeah, I shall catch you next week. Thank you for the 50 bits, RHK, most appreciated. And enjoy Shelby or enjoy your Friday afternoons, whichever you choose to do. And yes, Tuesday for more RC 2014, by the way. Bye all.